Hi everyone, in this video you have to find the first derivative of functions included trigonometric functions or inverse trigonometric functions. For part A, the function is y equals e to the power x multiplied by cosecant inverse of x. So you have to use the product rule because we have two functions multiplied with each other. So name the first one u and the second one v. Then you have to start using the product rule. So y prime equals uv plus uv prime prime. So first you have to find the derivative of the first function, which is u, and the derivative of e to the x is e to the x. So it will be e to the x, the same, times v, the second function, cosecant inverse of x, plus u, which is the first function, e to the x, multiplied by the derivative of the second function, which is v, and the derivative of cosecant inverse of x is negative 1 over absolute value of x multiplied by square root of x squared minus 1. So multiplied by negative 1 over absolute value of x times square root of x squared minus 1. Now you can simplify by take e to the x as greatest common factor from both terms. So we have e to the x multiplied by cosecant inverse of x minus 1 over absolute value of x times square root of x squared minus 1. And this is the simplest form of the derivative of the first function. In part B, we have the function h of x, and also the h of x is a function that have two functions multiply with each other. So you have to use the product rule again, and you have to name the first one u and the second one v. So h prime of x equals uv plus uv prime prime, which is equals to the derivative of the first function, which is x to the fourth power, is 4x cubed. 4x cubed multiplied by the second function, which is sine inverse e to the x to the 10th power. This is u prime times v, then plus u times v prime, and u is the first function, which is x to the fourth power multiplied by the derivative of the second function. But the second function you have to use the product, the power rule, because we have a function to the 10th power. So you have to put the power in front of the bracket, then the same bracket sine inverse e to the x all to the power 9 multiplied by the derivative of the inside function, and the inside function is sine inverse e to the x. And as you know, the derivative of sine inverse of a function equal to the derivative of the function inside divided by square root of 1 minus the inside function squared. So this will be multiplied by the derivative of the inside function, which is e to the x, divided by square root of 1 minus the inside function squared. Now the inside function is e to the x, so e to the x squared equals e to the 2x. Now by simplifying and take greatest common factor between two terms, it can easily see that we have between the two numbers 4 and 10 we have the greatest common factor 2. Between x to the third power and x to the fourth power we have x cubed, and between the bracket sine inverse e to the x to the power 10 with this term sine inverse e to the x to the ninth power, we have the greatest common factor sine inverse e to the x all to the ninth power. Then you have to open a bracket, and what we will write inside. Firstly, 4 divided by 2 equals 2. Since we take x power 3, there is no x power 3. Then we have GCF sine inverse e to the x to the power 9. So in the first term it will be sine inverse e to the x without any power. Then plus, for the second one we have 10 divided by 2 equals to 5, x to the power 4. Since we take x power 3, remains x. Then we have the function e to the x divided by square root of 1 minus e to the 2x. For more simplify, you can delete 5x from here and put it in the numerator of this function, and you will get 5x e to the x in the numerator, and this is the final answer of part B. For part C, we have the function f of x equals tan inverse of sine x divided by x squared minus 1. To find the derivative of this function, you have to note that the inside function for tan inverse is a quotient between two functions. So you have to use the quotient rule to find the derivative of the inside function. And as you know, the derivative of tan inverse of a function equals the derivative of the function divided by 1 plus the function squared. So name sine xu and name x squared minus 1v to find the derivative of the inside function of the function tan inverse. So as you know, now we will deal with the inside function. The inside function prime is uv minus uv prime over v squared. This is the derivative of the inside function, and this is equals to u prime, which is cosine x, times v, which is x squared minus 1, minus u, which is sine x, times the derivative of the denominator, and derivative of the denominator is 2x, divided by v squared. X squared minus 1 squared. This is the derivative of the inside function. Now to find the derivative of overall function, to find the derivative of f prime of x, this is the derivative of the inside function divided by 1 plus the function squared. So 1 plus the function squared, and the function is sine x over x squared minus 1 all squared. Since we have two denominators, you can combine them in one denominator, and you will get the final answer for this question. So f prime of x in the last form is equals to x squared minus 1 multiplied by cosine x minus 2x sine x divided by x squared minus 1 squared multiplied by the big function 1 plus sine x over x squared minus 1 squared. In part D, you have to find the derivative of the function h of x, which is cotan inverse of 3 to the x e to the x plus sine x all to the power negative 1. So here you have to use the power rule, because we have a bracket to the power negative 1. So h prime of x, put negative 1 outside, multiply by the same bracket cotan inverse of 3e to the x plus sine x, then subtract 1 from the exponent or the power, and you will get minus 2, minus 1, minus 1. Then you have to find the derivative of the inside function, and the inside function is cotan inverse of a function. So you have to find, firstly, this is derivative of cotan inverse of u equals negative y prime divided by 1 plus the inside function squared. So you have to multiply it by the derivative of the inside function firstly, and the derivative of the inside function is 3e to the x plus the derivative of sine is cosine x divided by 1 plus the function squared. So 1 plus the function is 3e to the x plus sine x all squared. Now pay attention, here we have negative sign, so you have to put minus the derivative of the function. So the answer will be like this: h prime of x equals negative 1. We can write negative, since we have negative 1 here times negative here, it will be plus. So we will cancel negative 1 with the negative sign here, and you will get cotan inverse of 3e to the x plus sine x to the negative 2 multiplied by 3e to the x plus cosine x divided by 1 plus 3e to the x plus sine x squared. And this is the final answer of part D. Now the last part, which is part E, but first you have to remember that the derivative of secant x equals to secant of x tan of x, and derivative of number to the function equals the derivative of the exponent multiplied by the same function multiplied by len the base, len a, and the derivative of len a function equals the derivative of the inside function divided by the inside function. And remember that the derivative of tan inverse of x equals 1 over 1 plus x squared. Now we will start with the function we have in this question of x equals bracket to the power 10. So you have to use the power rule firstly to find the derivative. So h prime of x equals, or sorry, f prime of x equals, you have to put down the power. So 10 multiplied by the same bracket we have 3x squared plus 5 to the secant x minus ln tan inverse of x. Now you have to subtract 1 from the exponent and you'll get 9. Then you have to deal with the inside function inside the bracket, okay, and you have to find the derivative of the inside function. So open bracket again. Now the derivative of 3x squared is 6x plus the derivative of 5 to the secant x. Firstly you have to find the derivative of the power, which is secant x, and derivative of secant is secant x tan x multiplied by the same function 5 to the secant x multiplied by len the base, len 5, then minus the last function is len tan inverse of x, the inside function is tan inverse of x, and the derivative of len equals derivative of the inside function divided by the inside function. Derivative of tan inverse of x is 1 over 1 plus x squared. This is derivative of the inside function divided by the inside function, which is tan inverse of x. Now for more simplify, you have to combine these denominators and put them in one denominator. So the final answer will be f prime of x equals 10 multiplied by 3x squared plus 5 to the secant x minus len tan inverse of x to the 9th power multiplied by the bracket, the second bracket, which is 6x plus, for more convenient you can write this one firstly, so we have 5 to the secant x multiplied by secant x multiplied by tan x multiplied by ln 5, then minus 1 over, now you have to combine these denominator and put them in one denominator, so we have 1 plus x squared multiplied by tan inverse of x. And this is the last simplify for the first derivative of the function of x. And that's it. Thank you.